A photodiode is an optoelectronic device which converts light energy into electrical energy. Now the working principle of this is exactly opposite of an LED. LED will convert the electrical energy into light energy. So as we forward bias more and more the LED, then more and more light will be emitted. Here, as the energy of the light increases, the electrical energy or the current through the photodiode will also increase. Now for the proper working of a photodiode, we need to reverse bias this PN diode. Now here the light is made to fall on the depletion region. Now to know about the depletion region, I have already explained in the video. There is a formation of a depletion region in a PN junction, and the link is given in the description and you can watch. Here the light is made to fall on the depletion region. If the energy of the light, that is h nu, is more than the forbidden energy gap, more than or equal to, then only this will function. Why? Because if we explain using the energy level diagram, I'll take only one diagram here. When the electrons are liberated, see, this is the valence band and this is the conduction band, this is the valence band and this is the conduction band, and electrons require this much energy, that is nothing but the forbidden energy, to go from the valence band to the conduction band. Then only in the valence band holes are created, in the conduction band electrons are created. That is, electron hole pairs can exist only when the electron acquire the energy equal to or more than Eg. So to make the electron hole pairs in the depletion region, the light should have the energy greater than or equal to the forbidden energy gap of this photodiode. And when the electron hole pairs are generated near the junction, they tend to recombine again. Say, let us say here, one electron is generated here, one hole is there, it will tend to recombine. But here, it is reverse biased. When it is reverse biased, the electric field come into picture. I have explained the effect of the electric field in the formation of the depletion region. You can watch again. And this is the direction of electric field. What is the direction of electric field? Because here negative ions are left near the junction, negative ions, and this side positive ions are left behind. Now electric field will be from higher positive to the negative. Therefore this is the positive, this is the negative, and this is the direction of electric field. Now since there is a electric field near in the junction, the electrons will move opposite to the direction of electric field. So the electrons which are generated when the light falls on the depletion region, they will move towards N side, and holes will move towards P side. E plus, I'll write, not proton, holes. Now they will not recombine. Electrons will go towards the N side and holes will go towards the P side. And now the current flows. And current is not due to the majority charge carriers. Majority charge carriers never cross the junction. Majority charge carriers go away from the junction. So the current is due to only the minority charge carriers. So what is the VI characteristics? VI characteristics will be drawn in the third quadrant. This is I. Okay, this is IR. This is VR. This is not there. Okay. Now it will be like this. This is for first intensity. For one intensity, as the intensity increases, the number of electron hole pairs increase, and therefore current also will increase. This is the second intensity, which is more than the first one, and it will continue like that. Now why this diode has to be reverse biased? What happens when it is forward biased? See, we take one example and try to explain this. Let us say when the diode is forward biased. When the light is not there, some amount of current flows because there will be temperature and the diode is forward biased. Due to the forward biased diode, there will be some amount of current flows. Let us say there are 1000 charge carriers. Now the current due to 1000 charge carriers flows in the diode. Now when the light falls on the diode, let us say 10 electrons are generated, minority charge carriers, because current is due to minority charge carriers here. So totally the charge carriers will be now 1010. Now what is the change in the current? Before the light falls, the current was due to 1000 electrons. Now when the light falls, the current is due to 1010 electrons. We cannot make out the change in the current. But when it is reverse bias, current, when the light is not there, there will be 10 electrons, let us say. These are 10 charge carriers, let us say. These are the minority charge carriers. When the light of same intensity falls, 10 electrons or 10 minority charge carriers are generated. So totally this becomes 20. Change can be observed more here than here. So you can have a lesser sensitive instrument to measure the current in this, but here you require more sensitive instrument to measure the change in the current. So that is why to make the diode sensitive, the diode is made reverse bias.